This question is to determine local maximum and minimum values for a piecewise function. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. Let the function f of x be defined as follows. If x is greater than 0, then f of x equals x raised to the power of 1 over x. If x is less than or equal to 0, then f of x equals 2 times x minus 1. Determine all the local maximum or minimum values of the function f. First, we start by analyzing differentiability at x equals 0. First, we consider whether the function f is differentiable at 0. When x is less than 0, the derivative of f is simply 2, since it is the derivative of a straight line. When x is greater than 0, we consider the function x raised to the power of 1 over x. To differentiate this, we first take the natural logarithm of f of x. So the natural log of f of x becomes the natural log of x divided by x. Then, using the chain rule, we find the derivative of that expression, which is 1 minus the natural log of x divided by x squared. Multiplying this back by the original function, we find that the derivative of f for x greater than 0 is x to the power of 1 over x times the quantity 1 minus the natural log of x, all over x squared. Now, as x approaches 0 from the right, the natural log of x goes to negative infinity, so the expression becomes very large in the positive direction. This means the right-hand derivative goes to infinity. From the left, the derivative is a constant too. Therefore, the function is not differentiable at x equals 0, and we must analyze that point separately for Extrema. Then, next step, finding critical points for x greater than 0. To find where f might have a local maximum or minimum in the positive domain, we set the derivative equal to 0. That gives us the equation, 1 minus the natural log of x equals 0. Solving that, we find that the natural log of x is 1, which means x equals the constant e. So x equals e is a critical point. Next step is to determine the nature of the critical point at x equals e. Now we test whether the critical point at x equals e is a maximum or a minimum. Looking at the behavior of the function x to the power of 1 over x, we note that this function is known to have a minimum at x equals e. This is supported by checking the second derivative or simply analyzing the shape of the function near e. Thus, we conclude that f has a local minimum at x equals e, and the minimum value is e raised to the power of 1 over e. After that, we check the behavior at x equals 0. Next, we look at how the function behaves around 0. As x approaches 0 from the left, f of x approaches negative 1. As x approaches 0 from the right, x to the power of 1 over x approaches 1. So the left-hand derivative is positive, and the right-hand derivative grows very large. This means the slope on both sides is increasing. Therefore, there is no extremum at x equals 0. However, for completeness, f at 0 is equal to negative 1. Final answer. The function has a local minimum at x equals e, where the value is e raised to the power of 1 over e. There is no local maximum. Whenever you encounter functions where x is raised to a power involving x itself, like x to the 1 over x, using logarithmic differentiation simplifies the process a lot. Also, don't forget to carefully test the point where the piecewise function switches, because extrema often occur there too. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.